This is a Zoom video conference for September 24th. It's on Tuesday because we're going to have a test on Thursday and Friday of this week. So here's the agenda of the things we're going to talk about. As I just mentioned, we're going to have test 2 on Thursday and Friday, 26th and 27th. It's going to be over a 48-hour period, so you got a time to take it. I think it's an hour and 15 minutes that I give you. I think that's more than enough time. I would recommend that you make sure that you've got good Wi-Fi and your computer's working, and don't wait till the last minute, okay? Be sure, in fact, I would do it way before midnight. If you plan to do it on Friday afternoon or Friday night, that's fine, but maybe go do it before 7 or 8 o'clock, because if you wait to the last minute and have a problem, you won't have time to recover, and you might have to call me and see what in the world's happening, okay? So be sure you figure out when you're going to do it, and I wish you all luck. Now, I've got the items here that are going to be on the test. Actually, it's going to be very much like the homework. You will need to understand numerical and categorical data and be able to distinguish between the two. You need to be able to identify sampling methods. And we're going to go over each one of these items in a moment and actually work some problems. You're going to have to look at and interpret graphs, charts, and frequency tables. And then with your calculator, calculate the 5-number summary of data with anywhere between 15 and 25 points of data, and then be able to calculate the standard deviation of a data sample. When you put all this in your calculator, you'll automatically get the standard deviation. I can't overemphasize the need to be careful when you put the data in. When you put the data in, you check it. You put those 15 or 20 data points, make sure you got them in correctly, and then maybe do it twice. The calculator works fast enough that you can probably do it twice and check that you've got it correct. I tell you, before we start looking at some of these examples, does anybody have any questions that were outstanding or things that you needed to understand, didn't quite understand?
No, sir, not right now.
Okay. Nobody else? Okay. As we go through this, you know, we've been through a good bit of this before. And if you have done your homework and looking at the class list, y'all have done a pretty good job of getting the homework done. There are maybe 2 to 4 students who have been behind on that, and I'm not sure why. But if you don't get the homework done and don't understand how to do it, it'll be hard to pass the test. If you need any help, please call me, snap a picture of a problem that you need help on, and text it to me. I'm willing to help anytime, but you need to stay up with this, okay? Now, it is possible for me to give a person a little more time on some homework if there is some kind of emergency, but you have to share that with me. There was a student who had to have some surgery, and I confirmed that, and I gave the person another couple of days to do the homework. But if you don't have an excuse other than forgetting about it, you know, I can't give you more time. But if you need help in catching up, I'll be glad to do that. Okay, so let's look at a few things. Different kinds of data, quantitative data and categorical data. These are just examples of, let's look at categorical data first. That really doesn't necessarily have a number attached to it, so it's not quantitative, like your gender, your religion. If you're having medical issues, what the method of treatment might be, the type of teaching approach your professor might have, your marital status, what your qualifications are, what your language is, the type of instruction. I mean, you could go on and on and on. There are some that are categorical that might sound like they are quantitative, like zip code. My zip code is 30248. I don't, 30, what's the Swainsboro zip code? 30401. I can't remember. I lived in Swainsboro 15 years. Now I'm up in another place. But anyway, there's no difference between these two zip codes. The fact that this zip code is larger than that one has no bearing on anything. I guess you can think of some others, like the year you were born. But any data that is numerical, that you can compare it with others, that would be quantitative data, like how high you are, what's your weight, what's your income, the size of your university, your group size, any kind of test scores, percentage of lectures attended, clinical skills performance. This would be a test that you might take if you were, say, a nursing student. The number of errors on a test, your age, the list goes on and on. I think you guys should have no problem dealing with this kind of data, categorical and quantitative. Now, you will have to identify various sampling methods, and most of these are pretty clear as to what they are. Convenience sampling, if you wanted to sample customers in a store, you could go to the store and just take the first 5 customers that come in and ask them questions, and that's just at your convenience. Or you could be walking down the street and just try to get 6 or 8 people around you and use them to take some samples. I'm going to get to cluster sampling and systematic sampling in a moment with some pictures, but simple random sampling is maybe using a random number generator to randomly pick so many people from a group. Excuse me, I should have said that cluster sampling and stratified sampling I'm going to talk about next, but systematic sampling would be something like going into a big auditorium and taking every 5th person that comes in and taking data on them. That would be systematic, like every 5th, every 10th, or something like that. But the two that some people get a little bit confused on is cluster versus stratified sampling. And in both cases, you're breaking the population into groups. And I'm just going to go straight to the picture. In both stratified sampling and in cluster sampling, you're breaking the population into groups, like group 1 to group 4. In stratified sampling, though, you take samplings from each group. You use a lot of resources to do that, and so you're going to be taking a lot more samples. In cluster sampling, you're breaking the population in maybe to the same groups, but maybe in order to save money or to think that maybe group 1 and group 2, group 4 represent the population pretty well, you're using less resources and you just take maybe two samples from 2 different groups. So that's the difference between stratified and cluster sampling. Now, you're going to have to be able to look at various kinds of charts, histograms, and so forth, and just look at it and pick data off of it and answer questions about it. Here's maybe the birthdays of students by month, and heck, maybe a classroom or a school. And it tells you for each month how many students have a birthday in that month. And so you might have to answer a question like, students with birthdays in the cold months, November, December, and January. So how many is that? You have to be able to read the graph and see that there's, if I'm reading this right, there's 4 there. There is 7 here. If I make a mistake, let me know. And there's 3 here. So that's 11 plus 3 is 14. So the answer to that is pretty simple. Okay, in the hot months, June, July, and August, how many have birthdays? Well, that will be the data from these 3 months. And so that would be 10 plus 6 plus 1. So that would be, if I'm adding correctly, 17. If anybody has any questions, stop me, or if you see me make an error here, stop me. Interpreting a pie chart. You see these all over the place. This is a stationary shop, how their sales are broken up in a given month. And here it's colored with different colors of the pie. And of course, each piece of the pie is proportional to the percentage of sales. And it's taken, in order to do it with a circle of 360 degrees, then say the one with the pencils here would be 0.37 times 360. That's how many degrees you would make it, whatever that is. But I think you know how to make a pie chart. If $10,000 was, and I put these numbers down to make it easy to multiply, with $10,000 was the total sales in 1 month, and it was broken up according to this pie chart, what was the total sale on pencils? Well, pencils, if I'm looking at this color correctly, and on the test, it should be real clear the way everything is marked off, although it won't be color, I don't think. So it's going to be 37% of the total. Well, 37% times $10,000 is $3,700. Well, they sold a lot of pencils. Books would be 19%. And of course, that would be 0.19 times 10,000 or $1,900. So I'm sure you'll be able to do that very easily or something similar. Now we have frequency charts, and I just threw this together pretty quickly. This is the weight of a group of people in different bands of weight, all the way from 120 to 269 pounds. And I believe the data was 100 people. That's going to make it pretty easy to do some of this. And so there were 4 folks between 120 and 134, 14 between 135 and 149, etc. And we want to do, first of all, I want to do the cumulative frequency. So it's 4. And now we'll add the 14 to that and get 18. By the way, we should eventually get to 100 if we're doing this right. We add 16 to this, and that should be 34. Let's add 28. Is that 62? Just doing this in my head. 62, add 12, that would be 74. Add 8, you get 82. Add 7, you get 89. Add 6, and you get 95. I think we're going to make it here. Then add 2 and you get 97. Add 3 and you get 100. So the cumulative should end up at the very end on the far right side be the total number of samples that you had. So you might have to fill out a chart like this. Obviously, to do the percent is pretty simple. If this had been a number other than 100, you'd still divide the frequency by the total number. So this would be 4%, 28%, 12%, 6%, etc. I know you can do that with one hand tied. And here is the same information in a histogram, and it just reflects all the numbers you just saw. So you might see numbers in a histogram and be asked various questions. Like, let's just think of some. How many weigh less than 150? Okay, well, that would be this group and this group. And that looks like 14 and 4. And I can look back at the data and make sure, yeah, 14 and 4. That would be 18 out of 100, or 18%, way less than 150. That's pretty simple. And I know you guys see this kind of data all over the place on television, on your computer. Now we get to number crunching. We have a lot of data here, and rather than, I think I left this on my, I hope it stayed in my computer or in my calculator. Let's see if I did. Okay, let's look at the data. Okay, hooray. I know you didn't want to sit there and watch me put all this data in the calculator, but I hope that everybody by now has a TI-30XS or a calculator that will take data and put it in a list just like you can here, and then do the 5-number summary, the standard deviation. It looks like, unless something messed up, I've got all the data in here, 79, 77, et cetera, et cetera. So we're asked to find the 5-number summary and the standard deviation. As we go through here, we'll automatically get the mean. So I'm going to hit second, stats, variable stats. We're getting it from L1, so just hit enter. If you had put it in L3, you would have had to select it L3. And then the frequency is going to be 1. And now you're ready to do the calculation. As we knew, there are 40 data points. The mean is 81.75. The standard deviation is 9.55. And you'll see I'll have all this written down on the next slide. The minimum is 54. That's the lowest score. The first quartile, which means 25%, was from 54 to 75.5 with 25% of the data. The median, the midpoint was 84. The third quartile is 87.5. And the max was 99. And this is a summary. Minimum, first quartile, median, third quartile, maximum, standard deviation, and the mean. Now, basically, I have shown you everything that you're going to have to be able to do on this test. There's not a single calculation that's on the test that's coming up that's going to be much different. It'll have different numbers. It may ask you slightly different questions, but it's all being able to interpret data and do accurate calculations. So that's basically what I have. That's about, I guess, 25 minutes of sort of review, but I'm willing to take any kind of questions from anybody. So any questions? Don't hear any questions. Is everybody there, or did you go to sleep?
Everybody, well, I'm here.
Okay, you're here. You didn't go to sleep?
No, sir.
I think y'all are a fine group, by the way. Did anybody see anything very difficult here? Maybe share some things with me. What have some of your thoughts been on how to do this work? What was the most difficult thing for somebody here, or was it all pretty easy?
I
Or
feel like
what did you have to learn to do? Anybody?
I guess the standard deviation,
Okay.
doing it in the calculator made it a lot better.
Absolutely. I tell you what, I have been doing statistics and mathematical calculations and calculus for a long, long time, since I was at Georgia Tech and graduated 50 something years ago, when there were no calculators. We had something called a slide rule, which you probably never even heard of, that we tried to use to multiply and do various things. And I hated to do standard deviation. If you had a bunch of data, you've got to take, let me, let's do something in red, like X1 minus the mean, square it. Take the next data point, X2 minus the mean, square it. Keep on doing this till you get to the nth one and subtract the mean and square it and divide that by n minus 1, which is very close to n if it's a large number, and take the square root of that. Now that's pretty simple to look at and do, but sitting there and putting all this in your calculator and squaring it can take a little time. So being able to just put x1 through xn in your calculator is a real advantage. You still got to watch out, make sure you didn't mess up on any of the x's. But if you do that, you're good. You know, life gets complicated in some of the things we have to do, so we need some tools. Does anybody have any other questions? I'm available all this week if anybody comes up on some questions that might be confusing. I'm going to be in a few minutes making a video for some of the next sections on functions. So that's what I'll be doing, but I'll be available to answer any questions. Anybody else got anything to say? If anybody wanted to text me or talk to me about something, feel free to do it. I'm going to stop the share. Let's see if anybody else has joined. I think it's still the same group. I will put the recorded video up in just a little bit. Nobody has anything to say?
No, sir.
Okay. Well, everybody have a good evening, and you guys take care. And if anything is concerned, you got anything of concern you need to talk about, give me a call. So I'm going to stop the share. I'm going to end the meeting. So y'all take care.
Thank you.